Welcome back. The objectives of this video are to introduce simple counting principles. We'll do some problems with replacement and without replacement, and we'll introduce the fundamental counting principle. The last two sections of this chapter will present brief introduction to some of the basic counting principles and their application to probability. In this example, we are going to look at selecting pairs of numbers at random, but we're going to look at them with replacement. Considering I have this box here, okay, and I've got 8 cards numbered essentially ace or 1 through 8. I'll reach into the box. I want to choose numbers that add to the sum of 12. But in this sample, I'm going to do it with replacement, meaning I pull a number out, 7, and I can put it back in, and I will continue to do that until I get sums of 12 out of the 2 cards. Now these two I picked up isn't a sum of 12, but the fact that I picked up the 6 is important because with replacement means that I could choose a 6 with my first choice and then choose a 6 again with my second choice. In this scenario with replacement, I can choose 6 twice, and that would be part of my sample set or my solution that would add up to 12. We show here the number of ways we can get a sum of 12, and there are 5 different ways. Sometimes we would call these the winning possibilities or the winners. Now in the second example, now we're going to take a look at the same scenario, but we're going to do it without replacement. Again, we reach into our box, we pull out at random a particular card. I pulled out an 8, so now I put that card aside, not back into the box, and I can't choose that card again. So in the example earlier, when I chose the 6, now that I've chosen the 6, I've pulled that aside. I can't choose 6 again because it's not in the box. That is without replacement. I'm not replacing. And as you can see here, now we can only get a sum of 12 4 different ways. So we can't choose 6. It's not one of our options. So there highlights the difference of with replacement and without replacement. And finally, in our next objective, we're going to look at the fundamental counting principle. So it's not always feasible or reasonable to write out all the possibilities. Here with the deck of cards, we certainly could do that. It was easy enough to write out all the possibilities. Fundamental counting principle is used when you have 2 or more separate events, like rolling a die. Okay, we roll the die, we roll the die again, we roll the die again. Those are all separate, different, unique scenarios. Or what we like to do quite often is flip a coin. Flipping a coin is a little bit easier because you can either get heads or you can get tails. The fundamental counting principle can be extended to 3 or more events. Is if we have 2 events like flipping a coin, the first event can occur in how many ways? Well, flipping a coin, it can only occur in 2 ways, heads or tails. As opposed to the die, it can happen in 6 ways. You can get a 1, a 2, a 3, a 4, a 5, or a 6. Event 1 can occur in 2 different ways. And after that occurs, then event 2 can occur in how many different ways? The number of ways 2 events can occur is essentially M1 times M2. Fundamental counting principle says that hey, if I flip a coin, what's the probability a coin can be flipped heads 3 consecutive times? Well, since each toss is independent, every toss, 1 out of 2. So 1 out of 2 times 1 out of 2 times 1 out of 6 is 1 out of 8, I beg your pardon. I was reaching for my die already. With the die, something can happen 1 out of 6 times. So if I wanted to roll, snake eyes 3 times in a row, that would be 1 out of 6 times 1 out of 6 times 1 out of 6, or 1 over 6 cubed. And let's take a look at one more final example using the fundamental counting principle. Telephone numbers in the United States currently have 10 digits. The first 3 are the area code, and the next 7 are the local telephone number. How many different telephone numbers are possible within each area code? And note at this time, a local telephone number cannot begin with 0 or 1. We're not asking about the area code, so we're going to eliminate those for a moment. And then our local telephone number can begin anything for 2 up to 9. So that's 8 possible choices. And then the second digit can be anything between 0 and 9, so 10 possibilities. Now this does have replacement. All the numbers are still in the pool, so we have 10 possibilities for the second choice, 10 possibilities for the third, 10 for the fourth, 10 for the fifth, sixth, and seventh. Each one of those has 10 possibilities, because you can always draw the same number twice because we have replacement. Using the fundamental counting principle, our event 1, M1, is 8 times, but then we have 10 possibilities for each of the remaining choices. So we multiply all that together and we get 8 million possible local telephone numbers within each area code. And that wraps up our introduction to counting principles, and we'll get some more practice with this when I see you in class.